2/3 of means multiplication, a number is x, translates into the equal symbol, and 5/6. Excellent. Thank you. How do I solve this equation? What should I do? Anybody, what do we need to do to simplify this or solve this equation? Anybody, please?
Multiply both sides by 3/2.
Excellent, because 3/2 is the multiplicative inverse of 2/3. But please remember, it's mandatory to multiply both sides. What do we get here? How much is this?
1.
Indeed, very good. Here I will simplify by 3. So I get 5/4, which can be changed into 1 1/4. Okay, another equation. 19 equals 2 plus 7/8 x plus x plus 7/2 plus 6. You can say this is a big equation. Not really. It looks like it, but let's think for a moment. Let's discuss this after a few seconds to see how we proceed. By simply looking at this equation, what will you say? What would you recommend to do first?
Combine like terms?
Yes. Yes. I will combine like terms, but what I would do is I will not combine these. They are like terms, but I will not. I will leave them alone. I will not combine these. I will only combine the 2 with the 6, which is an 8. And I will have to subtract it, move it to the other side. Positive 8, when I move it to the other side, 19 minus 8 is 11. Let's see what is left. I can also move the 7/2. Let's also move the 7/2. So these two were 8. I subtracted them from 19 because they're positive on this side. I moved it to the other side with a negative sign. So 19 minus 8 is 11. I also moved 7/2 to the other side, was positive on the right-hand side, is negative now. And I have just these two terms left on the right-hand side. They are the only terms that have the variable. Now I want to eliminate all fractions. Can anyone looking at this equation say, oh, I know you have to la la la. What do I have to do to eliminate all fractions? We're not afraid of fractions. We just want to make it easier. We're going to try to make this equation easier to work with. So we want to eliminate all fractions. This is what we always have in the back of our minds. Eliminate fractions. Good. So what should I do to both sides? Which treatment will you apply to both sides to eliminate all fractions? And you will say, please try. It's okay if you're wrong.
Multiply both sides by 8/7.
You mean by 8. In order to eliminate all fractions, we only need to multiply everything, all fractions, everything, every term. We cannot skip anything by 8. We only want to eliminate the denominators. But you're right. I did not phrase it correctly. It was confusing. So I should have said I only want to eliminate denominators. What I meant was when I eliminate the denominators, I eliminate fractions. But I didn't mean the whole fraction. So that was my bad. So I want to eliminate the denominators everywhere. But I cannot just pick and choose to multiply these two and forget about the rest. So when I multiply by 8, I have to multiply the first term by 8, the next fraction by 8 over 1, the next fraction by 8 over 1, and the last term by 8. Everything gets multiplied by 8. Please do not pick and choose. That will be a terrible mistake. I'm not saying you're going to do it. I'm just talking about the possibility. So this is 88. Here I simplify by 2. So I get negative 28. Oops. Equal symbol is right here. I simplify by 8. So I have 7x. And I multiply by 8. And I have positive 8x. So by multiplying everything by 8, I eliminated all denominators. Indirectly, all fractions. Any questions on this step? Is this clear? Okay, so now on the left-hand side we have 60. On the right-hand side we have 15x. Can anyone give us x? What do we need to do now to get x?
4?
Yes, indeed. Is it true? I have no clue. What will you do to verify whether this is correct or not?
Divide by 15 or put 4 as x?
Exactly. Go back to the original problem. Not here, not here, not here, nowhere else. But in the original problem and replace x by 4. If replacing x by 4, all this side, after performing all calculations, we get 19, I will come back and say yes. If performing all these calculations will not result in 19, I will say absolutely wrong, start from scratch. So let me share my screen and go directly to the calculator so it takes as little time as possible. You should always do this, especially on a test situation. So I have 2. And I have plus. Be very careful how you enter this. You either enter it at 7 times 8 divided by, times 4 divided by 8. Be very careful, because if you do not put it in this order, the calculator will do something else. And then plus 4. And then plus 7 divided by 2. And then finally plus 6. When I hit enter, if the answer is not 19, x, assuming I did not make a mistake in entering these numbers, if the answer is not 19, then x is not 4. Okay, any questions on these equations? Any questions? Okay, let's continue with 2.6 decimals. Decimal numbers. So, what are decimal numbers? 1/2 can be presented as a decimal number. If I divide 1 by 2, I get 0.5. This is so-called a terminating decimal number. It's fixed. It's 0.5. Nothing else follows. What about the square root of 3? Well, the square root of 3 is 1.73205, and so on and so forth. And this is called irrational, because it cannot be transformed into a fraction without approximation. You cannot. You can never change the square root of 3 into a fraction. Another example like this one would be 15 over 4. This is a decimal number with a terminating decimal. But for example, 1/3 is 0.333333 and goes on forever. This is a repeating decimal, which we normally like to write like this, with on top a bar on top of 33. Or let's say is 78, 78, 78, and so on and so forth. The same thing, 0.78 with a bar on top, meaning 78 portion repeats itself indefinitely. How do I change a decimal number, like for example 0.1, into a fraction? I put 1 at the top, and the number of zeros that follow the 1 is given by the number of decimal digits. If I have 0.3925, I have 3925, and I have 4 zeros, a zero for each decimal part. What if I have a 3.12? Then I have 312 and 1 and 2 zeros. Why 2 zeros? Because I have 2 decimal digits. You can also write it as 3 integers and 12 over 100. Same thing. Any questions? Okay, so let's look at another example. Like, let's say we are given 0.85 to change into a fraction. Okay, that's fine. That's easy. But what if now they're saying presented in lowest terms as well? Well, I see that they both end in 5 and 0, so they are divisible by 5. When I divide by 5, I get 19. When I divide by 5, I get 20. And this is it. This is the proper fraction in lowest terms, 19 over 20. Any questions so far? Let's talk about approximations. If I'm given 0.24, and they said to approximate to the nearest tenth, I look at the next digit, the following digit, and if this number is 0, 1, 2, 3, or 4, and I'm asked to approximate to basically the first digit, decimal digit, I cannot change the 4 into the next digit. I'm sorry, I cannot change the 3 into the next digit, which is 3. The 2 into a 3, because this number is 0, 1, 2, and 3, 4. So the answer will be this. But if I have 0.29, and I'm asked the same question to approximate to the nearest tenth, because this is a 9, and this is 5, 6, 7, 8, or 9, then I will have to increase the 10th digit and write this as 0.3. And it's the same thing for any other situation. If I'm asked to approximate to the nearest 100th, th, or to the nearest 1000th with th, that means first digit, the 10th, the second digit, the third digit, and so on and so forth. Let's look at one example. What if I have 0.3945 and I'm asked to round to the nearest 1000? How would you approximate this number?
Since it's 5 and higher, you round it up.
Yes, indeed. It would be approximated. I should use this squiggling because this is not equal, it's approximate. Now, if I'm asked to compare, let's say I'm asked to compare negative 2.44 with negative 2.42. Which one is bigger, which one is smaller? So both are negative 2. Both have the 4. So what I'm really comparing is the second decimal digit, which is this. And since they are negative numbers, I'm going to look at the real line or the number line. This is 0. This is -2. And then I have to go 44.44 or 0.42. But the -44 will be the -44 and the -42. This is a larger number because the 42 will be to the right of 44 because they are negative. So this is the correct inequality symbol. Is that okay? Is this clear? Yes, no, maybe. Do we need to compare other numbers? Okay, so let's compare. So 1.39 with 1.36. Which one will be larger?
1.39.
1.39 will be larger. Okay, let's look at -7.874 plus -25. Yes, I will allow you to use calculators. I'm okay with that, but we still have to understand how this works. First of all, they are both negative. Remember, this is a grouping symbol, but it does not have operations inside. It's used to separate two operation symbols. It's used to separate the positive from the negative. They cannot sit one next to the other. Okay, so in that case, I have the -7.874 minus 25. So when I have to add them because I'm adding debt, negative to negative. So when I do this, so this is what you have to do. The 25 has a decimal point following 5. So the rest you can put as many digits as you want. But 7, when we add and subtract decimal numbers, the period has to line up. If you don't have the period or the decimal point, one under the other, you cannot add or subtract. Which is not the case when we multiply or divide. So now I add, it's 874, I add, and I get 32. So the final simplified form is 32.874. So please remember, when we add and subtract decimal numbers, the decimal point has to line up. Okay, here's another example. 5.8 plus 4, quantity, another minus 7.3 minus 9. The first one is easy because I have 5.8 plus 4. So I only have to add the integers, so I have 9.8 minus. Now here, what will be the sign of the outcome? 7.3 minus 9. Will it be positive or will it be negative? And how do we know?
-2.3 because you're subtracting 7 from 9.
You mean
9 from 7?
Yes, but you mean 1.7. But let me explain. Yes, indeed it will be a negative number. Now, on the side, I have 9.0. Why 10? Because I only have one decimal digit. And 7.3. The decimal digits have to line up. When I subtract 3 from 0, I get a 7. But I borrowed from a 9. So 7 subtracted from 8, I have 1. So this is 1.7. Is this clear? Is the 1.7 clear? Now, the opposite of a negative number, or -1 times -1.7, we know it's positive. Again, when I add decimal numbers, I have to line up the decimal digit. They have to be one under the other. 7 plus 8 is 5, and I carry a 1. This is a 10 plus 1 is 11. And copy the decimal point. So the answer is 11.5. Any questions? Any questions? Let's look at some equations now with decimal numbers. So a minus 0.11a equals 0.89a. This is not an equation. I just want to make a point with this one. Then we'll look at equations. Now, when we see, these are like terms. We know that. There is an imaginary 1. When we say 2a, we mean 2 times a. But when we say a, we really mean 1a. So from $1, I subtract 0.11. From $1, I subtract 11 cents. I get 89 cents. So let's try. 1 from 0 is 9. 1 from 9, because I already borrowed, so it's 8. And there is no unit left here, so 0.89. So in other words, I'm saying 1 apple minus 0.11 of an apple multiplication. 1 minus 0.11 is 0.89a. Do we understand this step? Is this clear? Please say yes, no, anything.
Yes.
Okay. So let's combine like terms. 6.3x plus 4.5 minus 3x minus 8.7. Let's take 1 minute on this.